Hello, this is Raymond from EMSNow, coming to you here from Apex 2012 in San Diego. Today I'm joined by three distinguished gentlemen to talk about tracking and traceability, real-time visibility on the factory floor. On my left is John Agapakis, Director of America Sales for Microscan. And on my right here is François Monette. He is the co-president of Cogiscan. And further on to the right is Jason Spera. He is the CEO of Aeigis Software. Welcome, gentlemen.
Thank you. Thank you.
Well, traceability can, of course, be applied to many industries, for manufacturers. So let's narrow it down first on traceability for electronics assembly. Could we maybe go around and quickly have a definition for each one of your businesses on what is traceability for electronics assembly? Maybe Jason, we'll start off with you.
Wow, I got that question. Okay. Well, one of the problems in the industry is actually that the definition is varied, right, depending on the customer requirements. But in general, it's basically having a record of everything that intercepted the process and the product as it occurred, all the way from the point where it entered the production to the time it ships out. So every component, all the consumables, all the WIP transactions, the test data, quality, incidents, non-conformances, and so forth, anchored to the serialized unit itself.
Right. And François?
That's a very, very good definition, Jason, by the way. There's not much I can add to that. I would just say that the actual needs for traceability vary from one segment of the industry to another, from one company to another. Everybody ultimately would like to have a complete traceability of everything, but there's always a cost associated with that.
Right.
So the question is how much the industry is demanding, if it's a life-critical product or if it's just consumer electronics. Maybe you have different price points and different needs that can be answered. So you need to have sort of a modular, scalable offering to be able to do that.
Yeah, we're going to go into that, the scalability of solutions.
Okay, excellent.
Okay, John, perhaps?
I think, again, very good definitions from both. Our role is typically to provide the devices that are on the line and extract the data and feed them into the systems that both Cogiscan and Aeigis have software systems for traceability. So it really is to allow us to track. The way we see, for example, our role is to perform what we call track, trace, and control. The devices that extract data from the line that can be used to figure out where a part is, the track function, where a part was, the trace function, and where should we send it, the control function, which may be on ID, or it may be on more general inspection, quality, and a variety of other features.
Right. So today, of course, miniaturization and everything else is making the boards denser and denser. So for yourself, John, how do you overcome the challenges of denser boards, smaller components? How do you even put a label on them just to track them?
And that's
from a vision systems point of view.
Very good actually question. Clearly, if you go around the floor, you would see that virtually every board in every line is tracked, and it used to be that you used to put a barcode label on the board. But the real estate required for 1D barcodes is now severely affecting what you can put on the board itself. If you have all of us carry on us electronic devices smaller and smaller, from iPhones to iPods to every single device that we carry is becoming smaller and denser. So one of the enabling technologies that has allowed this transition and continued traceability was the advent of direct part marking and two-dimensional barcodes or two-dimensional codes, and more specifically data matrix codes about 15 years ago. Those codes are the highest, are rectangular, essentially have the form of a rectangular checkerboard, and allow you to put a lot more information in much smaller space. And also a very big difference from labels and 1D barcodes allow you to put the information directly on the part. Right. The reason for that is because the two-dimensional codes are digital versus the analog encoding of information that a 1D barcode can encode. So that's really the biggest, I think, most important enabling technology that allowed us to go and extend the traceability down to the smaller and smaller devices. As an example, in the edge of every flat panel display, you will see 2D codes that are now down to 1 millimeter by 1 millimeter square. and etched in the glass, directly on the glass in the border of the flat panel.
Okay, so taking up what John has said, and for you guys, you're the software provider, and for you, the system integrator, how do you see data acquisition, as well as data capacity, as well as data management for the overall system for traceability from start to finish? To track.
That's a good question.
Maybe François? Yeah, go ahead.
Sure.
Yeah,
Okay,
sorry.
no problem. Well, essentially, what John mentioned is, 2D technology is definitely becoming more and more prevalent. Ultimately, what we see today in a typical factory is a combination of different technologies. We have some items are identified with 1D barcode, like component labels, for example. Some are with 2D labels or direct part marking. Sometimes with RFID. So, and so in some cases we need some vision systems, sophisticated vision systems to be able to acquire this information. Right. So it's a wide range of technologies. The idea is you take all these technologies, you capture all the data from various inputs and standardize that in one database that then can feed this data to our level systems. Right. So that's the whole objective here.
Jason, from your point of view?
Actually, it's interesting. The technology John mentions has ramifications for systems like ours, because what you're talking about in some cases is the actual intelligent ID is not present on the product until further down the process. So that impacted our customers, automotive in particular actually, where the ID isn't on it until the very end of the primary line. And we had to architect our system so it can handle complete level 4 traceability in the absence of an ID until the end of the process, which is kind of a counterintuitive situation, but it comes up all the time. So whether you're on placing or you're burning the ID onto a component or somewhere once real estate is available for it, but the software systems have to handle that inherently, and it was quite a challenge at first, but now this is how things are going. Real estate is disappearing and there have to be solutions for that.
Right. And just to go on about the reduction of errors, obviously accuracy is very important, but speed is important as well. So how are these two qualities achieved while implementing traceability? Maybe John, you can go.
Speed, you mean in terms of scanning?
Yes. How quickly can you acquire the data, or how quickly can you find out what happened or what's wrong on the line?
There are two aspects of that, and I will deal with what's going on the line, and then my friends can take it up in the database and the rest of the software. On the line, the good news is the machine vision technology, that is what is used to extract the information from the board or from the component and to read the data matrix code, has become faster and faster. As our computers and microprocessors become faster and faster, so are the vision systems and the barcode readers that are used to extract this information. So in milliseconds we can acquire, with some of our systems we can acquire 60 frames per second and process them depending on the application, depending on the configuration, in similar pretty high rates of speed, many a second. So this way, or much higher than that even in very high throughput applications. So we can keep up with the lines and the line speeds in terms of the acquisition of the IDs from every individual component as it goes through the production line.
Okay, Jason, your point of view on speed and accuracy?
It's a good question because we take it from there. And in large installations, the problem is not so much the acquisition of the ID that passes from the device, it's that the customer wants so many checks done against that, and it can't exceed the beat rate of the line, obviously.
Correct.
So now you're talking about sometimes 15, 20 different checks, whether it's too many yield problems at functional test, it could be material problems at that point of use, or anything. So we had to architect our system to be highly scalable at the logic layer. Thankfully, Microsoft and so forth has had these, because of availability concerns in large-scale enterprise systems, there's technologies that are really remarkable. So even in large multi-line plants with huge amounts of test data coming in, it does not bog down with a validation request. So the speed has not been an issue. I would say 8 years ago it was tough, but now the technologies exist to get over it.
François?
It used to be a few years ago where people would view traceability as the end result, and you had to spend all this money getting the data collection hardware and software in place, scanning all this data. It was viewed as an additional cost, to get the data into the traceability database. But the way we look at it is really traceability should be a byproduct almost of a good tracking and control system. What you're trying to do is get real-time visibility to get good and good response time for what's going on in the factory and how you react to that. and making sure that there's no errors. And if you do that really well, you're going to have full traceability as a result of that.
So obviously,
you mentioned that accuracy, and I don't think I addressed the question of accuracy, and probably is worth pointing out that contrary to the 1D barcodes, the two-dimensional barcodes have built-in error correction ability. So first of all, they're guaranteed to not give you the wrong number, the wrong answer. You may be able not to read it if the code is extremely damaged or obscured, but you will not get a wrong number, a wrong answer, and a wrong ID. Furthermore, even if you have a scratch or if you have a portion of the code missing, because of the built-in error correction characteristics of the code, you could be missing up to 20% or in some cases more of the code itself, depending on the type of damage, and still be able to reconstruct fully what the ID was in the code. Very different from a 1D barcode, where if you miss portion of the barcode, the best you can do is find out that you cannot read it, but you cannot reconstruct it.
Right. And so my next question is perhaps more relevant for both you guys, system integrator as well as software. Obviously, different manufacturers would require different solution sets to their challenges, and it does not make sense for them to invest in a so-called box solution for overall. So how scalable and how modular are traceability solutions today? Jason?
Well, I think it probably could be said of both our solutions. They have to be modular, because not everyone can absorb, well, one, they might not have the requirement for everything, and two, sometimes the culture of a company cannot absorb a transition to a full MES system overnight, whether they wanted to or not. They just can't do it. They have to do it in a phased manner, and there's cost implications and so forth. So it has to absolutely be modular. If you're a medical manufacturer, you're going to need a tremendous amount of very rich data and control. But if you're just making commercial products, maybe not so much, and those have cultural implications to the company and cost impacts with the system and deployment time impacts.
François?
Absolutely, that's a very good point. And one of the issues is that typically people have a certain set of requirements at a given point in time, and these will evolve over time. As the technology evolves, the customer demand evolve as well. For example, more and more, it's not just getting the data from the equipment, getting the test result, getting those types of things. It's also, for example, if you're dealing with a vision system, you want to actually store and record the image. So if you have a problem in the future, you can see the image on the board, the image of the label, all this kind. So the amount of data and the amount of information that we need to store for traceability just keeps evolving over time.
Yep.
Right. So I'm sure to solve the problems of the manufacturer, you guys spend a lot of time just sitting down with them to understand their issues and their problems.
Absolutely.
Before you even come up with a solution.
One of the great things about our business is the customers have no lack of requirements that they're feeding us.
The
challenge.
The modularity and scalability extends all the way down to the devices on the line itself.
Yeah.
So in our case, in the readers, most of our systems, or all of our systems, really are scalable and modular. You can they take the form from anything from imagers, miniature imagers, to smart cameras, to PC-based vision systems with multiple cameras, digital cameras connected to them, all with the same software, the same interface that allows you to, again, scale up or down the solution depending on what the problem is.
Well, thank you, gentlemen, for sharing your considerable insight into this area of electronics manufacturing. Thank you so much. Yeah, thank you.
Thank you.
Pleasure.